This video is solely going to base on grouping like terms under algebraic expression. So if you have any question or if you have any difficulties in grouping like terms under algebraic expression, so this is for you. Now we are going to start from the simple ones and then you get to something that goes like this. So make sure that you stay here to the end. Now, before we start, you need to understand the clear meaning behind algebraic expression as well as grouping like terms. In algebraic expression, what it means here is that we are just using some alphabet. For sure, that could be English or alphabet, right? So maybe a different alphabet from different countries. So here we are using some letters, let's say A, maybe B, maybe not forgetting the X and the Y in mathematics, as well as Z. For sure, any variables that you can think of in English alphabet, we are using that to represent something that we already know, or maybe something that we don't know for some cases. Now what I mean by something that we know here is that what happens if you say that maybe I like food a lot. So let's say you are attending some restaurant or maybe a food joint and then you want to buy some items. So maybe because you are not the only person buying from that joint or maybe the industry, that is why we are using a variable to represent something, right? So let's say you go to a restaurant. So this guy here can be beans. Let's say beans. If you don't know what a beans is, maybe this is a favorite food in our country, especially for the youth. Or maybe another person can also buy, let's say rice, right? So buying rice. So this can be rice, maybe the combinations of the two. So maybe buying the two could be, so that's where these additions comes in. Have you seen how mathematics is using some letters and symbol to convey the real life problems, right? So that is what mathematics does. So this is where the algebraic expressions comes in. We are using letters to represent something, right? So anything that you can think of. Right, so maybe you are buying beans and rice at the restaurant. So let's say this is equal to, let's say, 10 cedis. Someone warned me at the comment that why do I always use the dollars? Maybe a dollar is a currency that can easily be converted into any different currency worldwide, right? So that is why you use that. So we apologize for using that symbol or currency all the time. So you can easily convert this into your own currency, right? So the combination of these two people give us $10, 10 cedis, 10 naira, 10, so on and so forth, right? So you are using this variable so to represent something that we don't know. Now this is a beans today and this is a rice. What about tomorrow? That could be anything, cocoyam or maybe yam, a fanta, and so on and so forth. So since we cannot be specific in one portion, that is why we are using a variable so to represent those things, right? That's just a simple meaning behind the algebraic expression. Now grouping the like terms means that we are grouping the same thing, right? So let's say what happens here, maybe it's today that you are buying just a beans. So this is a 1, right? So 1x, meaning that you are just buying just one plate of beans or something that goes like that. So let's say what about yesterday you bought 2x, right? So meaning that you bought 2x. Obviously now the key here, the grouping like terms here means that we are going to group the same thing, right? So I can see this x here, which is the same as the beans, and then another beans here, right? So beans all is equal to beans, right? So that's very simple. That is just the simple meaning behind grouping like terms. Now where the students normally get confused is where this x and the x squared are not the same in algebraic expression. That's something you have to pay a close attention to. So back to this example here, if I want to group these people, I can say that this and this one are the same, therefore they are going to be 3 of the x, right? So 2 plus the 1 here, right? So that's why we are having 3 of the beans, so plus y, everything is equal to 10, right? So something like that. But here, if you're having out these two people here, there's no way I can add these people. Does it make sense? There's no way I can add them because this is just x, this is beans, this is not the beans, right? So you have x squared. Obviously, so in algebraic expression you cannot add these two people, right? So that's very simple. Now make sure that you stay here to the end of the video to see how best we are going to group something that goes like this. If you have any question, make sure that you comment along. Now let's see our first example concerning grouping. This is something that we are having. You're having 3x and then plus what xy plus 4x and then plus 2xy. So you want to group the like terms. So the meaning of the like term is those that are similar, right? So those that are the same in the industry. So what I mean by the same here is that pay close attention. You cannot add this 3x to this xy, right? So the xy, anytime you see a variable attached to a number or a variable on its own, just assume that that is just one thing. So from the previous example, we assume that this is just the beans, the x is the beans, right? If the x is the beans, let the xy be another what, another item, right? So the xy, don't say this is the beans and then this is so, because they are working together. Obviously, that is the trick in what, in grouping under what, algebraic expression. So this can be anything that you can take of. So let's say this is just a Coca-Cola, right? So this is just a Coca-Cola, right? Right, let's say the xy, everything is just a Coca-Cola. So any variables that are working in pair, assume that that is just one. So to avoid any confusion on what algebraic expression, this is how best you can group the items, right? So that you can easily see another Coca-Cola from what, from this portion. Is that okay? So there's another Coca-Cola from here. What about this? This is going to be the beans, right? Have you seen how simple it's this in when you're able to change the variables to something that you already know, right? So here we are going to have a 3 of the x, so I can see another beans here, right? So remember the sign here is for the 4, so plus what, 4x, and then here we come back to this point, so we are going to have what, here is xy, and then we have another what, xy, so plus what, 2x xy. Is that okay? So this is going to be what, 7x, and then this is going to be, remember this is just going to be just the Coca-Cola, right? So there's a 1 here, right? So 1 plus 2, that's going to be 3 of the x and y. What about these people? Don't go beyond this, because this x and this sy are not the same. For that reason, beans and Coca-Cola are not the same, right? Have you seen how simple? So this is going to be our final answer, right? For this particular type of grouping. Now, if you're enjoying this video, don't forget to give us a thumbs up, subscribe to the channel for more content. Like, if you have any question on the algebraic expression, make sure that you check the playlist below, or maybe you comment in the comment section below for more. Now, let's look at a more complicated examples. Now, this is what we have. You have the 5x plus 4 and then minus 9y plus 3x and then plus 2y and then minus 7. Now I guess you can pause this video, just give it a try, and then come back and check the solutions. So thumbs up for trying, right? So no fear of making mistakes. So that is how best we can learn, right? So since a child learn how to work by falling down multiple times, right? So that is how simple. Never fear of making mistakes in mathematics, right? But make sure that you make all your mistakes outside any text or any exams. Now, from the start of this, we all know that this x and the x are going to be one place. So you have the 5x plus 3x, right? So this guy goes away. Is that okay? They go away. Now you come back to this point, right? So come back here. Maybe always, sometimes the variables first, right? So dealing with the variables, so we have you see, the trick here is that the sign in front of you, that is what belongs to you, not the one at the back, right? So what I mean by that, this guy is having negative, so pay a very close attention to negative, right? So you have a negative 9y. Is there any other y here? So you have another y, that should be plus 2y, right? And then come back, and then we are dealing with this guy is also gone, right? So we are done with these people. So we are left with this one. So that is just going to plus 4 and then what, and then minus 7, right? So here we know. Now in adding the algebraic expression, you just need, once you are able to identify that these people are the same, we know the addition and the subtractions of the numbers already. So that should be 5 plus or plus, so that should be 8x, right? And so what about this one? So this is going to be negative 9 plus or plus 2, right? So negative 9 plus or plus 2, that should be what, negative 7. Okay, so negative 7, so negative 7y. What about these people? These people, you are going to leave it minus 3. Now, can you proceed from this point? No, we cannot proceed from this point, because this is different, this is also different, and then this is also different. So this will be our final step in grouping something like this, right? Okay, perfect. Now what about questions? What about this question? this may looks a little bit horrible, right? But if you follow the strategy I gave you at the beginning of this video, you can see that this is something very easy, right? Very simple and easy to follow. Now we have what? 4x squared y plus what? 5x y squared, and then plus what? 3x squared y, and then minus 2s y squared. Just look for a family. So family, what I mean by the families of the rice, Coca-Cola, and so on and so forth, right? So now don't be confused here. This is x squared y. Is there any another x squared y here? Sure. So this guy is here, right? So we have a x squared y and then s squared y, and then what about this? This is just very simple, right? We have a 5xy squared. Is there any other 5x or maybe xy squared? Yeah, this guy. Is that okay? So I guess you should give me the answer to this particular question in the comment section below, right? So give me the values of this answer here in the comment section before we proceed to the next part of this video. Now that we have a very in-depth understanding of grouping like terms, let's see how to apply that in solving questions like this on the algebraic expression, right? So here we are going to simplify. That is what the question is saying, is simplify. Now the key here is that we're back in dealing with a fraction. So let's say 1 on 2 minus, let's say 3 on 4. The way of solving this thing is that you must find the least common multiple, right? So in simple terms, that's the LCM. Now if you don't know how to do something like this, just make sure that you subscribe to the channel, or maybe comment along so that we can send you the video relating to something like that. So but this is the idea that we are going to use in solving what something like this. Now this requires another step further, right? So what I mean by another step further is that looking at the guy here, that's the x squared and then minus 2, and then here we are also having s squared minus 3s plus 2. Now the meaning or the simple thing is that you have to make sure that these guys are what in the simple term. So what I mean by the simple term, this x squared here has to vanish, as well as this one also have to vanish. Now this requires you to know that this is going to be, this guy here is what maybe let's say difference of a 2 square, or maybe let's say quadratic. If you know how to solve quadratic equation, that is okay. So applying that method on this guy here, we are going to have s minus 2 as well as the s plus 2, right? So simplification of this guy here gives us some. If you don't know how we get this thing, just try and comment below, right? So we give you the details one by one. We have a videos on that. Maybe you should check the playlist down below for more lessons on this. Now here too we are going to have what 1, which is this guy here is going to be what, that should be s minus 1 as well as s minus 2. Solving this quadratic gives us something like this. So by a factorization method, is that okay? Now why are we doing this? We are doing this so that we can easily have a simplification. That is what the question says. So you should simplify. So maybe this is a little bit complicated, right? Now from this point here, what are we going to do? That is where we come to this guy here. So we are going to find the LCM, the least common multiple among these two people, right? So here we can see that this guy, the x minus 2 here, there's another x minus 2 here. So that makes us see that we are just going to have, let's say, 3 people at the down, right? So that's going to be our LCM. So from this guy here, so the LCM, so we know what to do, right? So you have a very long line here. The LCM is going to be the s and then plus 2, right? So this one here, maybe we should start from the s minus 1 so that you can see better. So s minus 1 as well as the s plus 2, and then here we already have the s minus 1, so there's no need for us to repeat that 2 times, right? So finally we have the x s and then minus 1. These are what our LCM. So what do we do with the LCM? So way back in this thing here, we have 3 on 4. The LCM of this thing is just going to be 4, right? So that should be just 4. So with this 4 here, is that okay? So with this 4 here, the 4 will multiply this, right? Or maybe the 2 will go into this one, how many times 2, and then multiply that by the top, right? So that is something we already know how to solve. So 2 will go into this one, 2, and then 2 multiply by the top one, that should just be 2, and then minus 4 will go into this one, how many times? 1, and then 1 will multiply the top one, that should be negative 3, right? So that is the idea here. So from this part here, we are going to see that this x minus 2 and then s plus 3. So this is going to be the whole denominator, right? So the whole denominator, that's the least common multiple here. So you can see that this and this cancel this one, right? So they cancel out, just like from the previous example with the number. So we are just going to left it so the x minus 1 and then multiply by what? The top one. Is that okay? Maybe I guess I should rewrite this so that you can see better. So I believe this will be better, right? So now with this one we can see better. So this is going to be what? Our LCM here at the down here. So this LCM means that this x minus 2 and then s plus 2 here can be found here, right? So this thing here will go into this guy here. So this one and this one cancel out. Is that okay? So you're going to left it with the s minus 1 and then 4 multiplied by the 4. Is that okay? Just the same scenario. So this one will go into this people cancel out, and then we are having the x minus 1. So if we are left with the s minus 1, what remains is going to multiply the one at the top, right? So we have 4 multiplied by our x minus 1. So make sure that you put this thing in the bracket. Is that okay? So let's see where the grouping of the line terms will come in. Okay, here, what about this one? So you can see that this and then this one, this and then this go away, right? So they all go away. So we are going to remember there's a negative here. So minus 1 multiply by what remains here. We have the s plus 2, right? Okay, so perfect. So from here we are going to expand the one at the top, right? So expanding the guy at the top here, that is what we do. We do the addition and the subtraction at the top, right? So way back in we do the fractions. So we have 4 multiplied by this one, that should be 4x, and then this multiplied by this, that should be minus 4. This multiplied by this one, that should be negative 4x, right? And then this negative 1 multiplied by negative positive 2, that should be negative 2, right? So here we are having it down here to be s minus 2, and then s plus 2, and then x minus 1, right? Now this is where the grouping of line terms is very, very important, right? So you can see that from the top here we have this one and then this one are coming from the same family, and then this and then these are also coming from the same family. So grouping that, we are going to have 4s and then minus x, right? So minus s. So here we have negative 4 and then negative 2, everything on s minus 2 and then s plus 2, then you have s minus 1. So here from the top you are going to have this, and this should be what? Is going to be 3x. Remember 4 minus 1, that should be 3s. What about these people? So that's going to be a minus 6 on what? All the denominator, that's the s minus 2 and then s plus 2 and then s minus 1. Is that okay? All right, perfect. Now from here, that is now going to be our final answer. We can do another simple simplification here. So this is what we had. So out of the top here, we can see that we can easily have the 3 here, and there's another 3 also here, right? So bringing the 3 out, then we are going to leave with just the x here, and then minus what remains here is going to be 2, right? So after doing this simple factorization, make sure that you expand the c if you are going to have the same answer. So for sure 3 multiplied by x will give us a 3s, and then 3 multiplied by negative 2, that should be negative 6, right? So down here we have everything. So the denominator, that is the s minus 2 and then s plus 2, as well as the x minus 1, right? So what is happening here? You can see the s minus 2 here, another s minus 2 here. So this one cancel this out. Is that okay? So this is where the question is asking us to do simplify, make everything into the simple form. So here we are going to have the s plus 2, and then we have here to be x minus 1, right? So this is from this guy here, there's no way we can do anything again. Now don't worry yourself and go expand this thing. If you do that, you are still doing the work more complicated, right? So this should be your final answer for a simplification. Now this is for you. So this is similar to the questions that we just solved, right? So now the key here is that always, this is just like a fraction, right? Almost similar to the one that we just saw. So here we are going to find the least common multiple. Now remember, before you find the least common multiple of something like this, requires you to make sure that everything is in what, in the simple form. So what I mean by the simple form, this guy, you can see these variables here are not carrying any number on top of them. So this is just what, in the simple form. So what about this, right? So this is where the question comes in. So your first step here is to make sure that you are changing this guy. That should be what, the down here should be equal to, that's the n minus 1 and then what, n plus 1, right? So n minus 1 and then what, n plus 1. Does it make sense? So very simple and what, and straightforward. So n minus 1 and n plus 1, right? So make sure that this guy and this guy, everything are going to be in the simple term. Now the key you should be asking, or something that you should be asking yourself, is what would be the LCM, right? So this is addition and subtraction being combined together. Now, for sure, dealing with addition and subtraction in mathematics requires you to always find what, the least common multiple, right? So that is the law. The law says that whatever you are adding and subtracting fraction, you should always make sure that you are finding what, the least common multiple. So what do you think would be the least common multiple if you combine this guy to something like this? So after finding that, that is where you go in step by step, just from what, the previous example. Now, once again, give me your answer to this thing in the comment section below, right?